What would Aristotle and Galileo say about a pirate that fell on a moving ship? Before I answer that question, you might be led to wonder, did Aristotle and Galileo, either of them, have anything to say about pirates on moving ships? And maybe not. I don't know if there'd be historical evidence for that. But it turns out they did talk about objects falling on a ship and whether it would make a difference whether the ship was moving or not. And I think for this example, I have some pictures with the answer. So I'm just going to go and toggle those now so that we can look at them. So here we have a roughly drawn picture of a ship with someone who I guess just maybe fell off the crow's nest or something like that. And it says down there, if a pirate falls from the mast of a ship that is floating at rest, he would fall straight down, landing next to the mast. So that's kind of shown right there what would happen. But contrast that to okay, if the ship is moving. And now we're going to see the Aristotelian point of view. So historically, this was a claim that Aristotle had actually made in his writings about what would happen if a ship were moving and you dropped an object. I've just made it a pirate for fun. But anyways, according to Aristotle, if the ship is moving, the pirate lands behind the mast since the ship moves and all objects fall straight down. So what does that mean? That means as the ship moves, the pirate just falls and would not land right in the same spot as if the ship were at rest. And the logic behind this for Aristotle, as it kind of says there in the explanation, is all objects fall straight down, pretty much always, was his logic. And it turns out, you might say, well, wait a minute, what if it's a projectile? What if I were to shoot a cannonball at that ship or something that doesn't fall straight down, or an arrow or something like that? And it turns out for Aristotle, that was really difficult. He had a really complicated explanation for that based on how the air maybe kept pushing that projectile based on the way it was shot. And it was very, very complicated because his notion was that all objects naturally just fall straight down by gravity. He just categorized that as what is natural for objects to do. Now let's contrast that to what Galileo says, because according to Galileo, the pirate's inertia makes him keep up with the ship's horizontal motion, thus landing next to the mast. So the picture of that is there, and the ship might be moving rather fast for the kind of ship that it looks like is drawn to be for this example and the way it's been shown to us. But nevertheless, Galileo would say because the pirate has inertia, which for Galileo, inertia represents the tendency that an object has to keep moving in a horizontal direction. For Galileo, horizontal was part of that statement. It turns out we will see that Isaac Newton and Newton's first law of motion kind of generalizes that to not necessarily only applying to horizontal motion. But nevertheless, for Galileo, this explains what actually happens. Because if you actually did this and the ship were moving fast, it's kind of like, a modern day example might be if I'm on an airplane and I drop an object, and maybe, I don't know, the airplane's going really, really fast, right? Maybe it's going 600 miles per hour or something like that, right? I drop an object. Does that mean the object is going to be deflected back at 600 miles per hour into my face? And if you've ever been on a plane and dropped an object, it just drops the same as if we were sitting here on Earth. And for that matter, we know that the Earth is also rotating and it's orbiting around the sun actually very, very, very quickly. And we don't notice the effects of that. And it turns out in Aristotle's time, they thought the Earth was at rest. So for Galileo, this idea was actually connected with the fact that Earth is moving, and that if pirates still fall in the same way, regardless of whether the ship is moving or not, in the same sense, objects will still fall the same way, even though the Earth is a moving object.